Hello, folks. I'm going to walk you through really quickly hierarchical multiple regression and testing all of those assumptions. I recommend following along in the module. It'll make this a little bit easier for you. So first, let's test some multivariate normality. We are going to go to analyze regression, a linear regression. This is a data set that you don't have access to, but it's a good example. So the dependent variable is anxiety disorder, and that goes in that part that says dependent, and the independent variables, and we're using two here, are waist to hip ratio and gender, and those are going to go in the independent section. So first, to test multivariate normality, which is the standardized and studentized residuals along with Cook's distance and the leverage values. Those are going to go, to get to those, you're going to click Save, because these are going to be outputs that are saved in our data set. And you're going to click, these are typically all unclicked, and you're going to go and click Cook's distance, leverage values, as well as standardized and studentized residuals. Click Continue, and you can see down here we're also including the covariance matrix, which you can use later on. So click OK, and in the output, you will see, sorry, not the output, in the data itself, you will see some new variables pop up here. The four studentized residuals, Cook's standardized, studentized residuals, Cook's distance, and leverage values. That's under data view. If you look under variable view, under label, they explain that, or they give a much better descriptive of exactly what each of those are, in case you didn't want to interpret that variable name. And in the module, you will also see all of the cutoff values for each of those for you to go through. So next, we're going to look at correlations, and correlations are outputted for you in the, you go to analyze, regression, linear again. So we don't save them over and over again because it will continue to save them with each run. I'm going to unclick those and click Continue, and we'll see the output. The first block is going to be the descriptive statistics, which will give us our means and standard deviations and the sample size for each of those variables that we're looking at. The top one will always be the dependent variable, or the first one will always be the dependent variable. The next block is going to be correlations, and there are a couple of ways to get to correlations. This is one, and I'll show you the other one. So the first one is correlations are included in the output for regression. This first big row is the correlation estimate, and the second big row is the statistical significance of the above estimate. The other way to get to correlations is to go to Analyze, Correlate, Bivariate, and you move all of the variables that you're interested in to the variable column. Click OK, and as you can see, these are going to be the exact same estimates. It's just going to look a little bit different. The smaller rows are going to be your parameter estimate, statistical significance, and sample size of whatever the bigger column and row are. Like I said, they're the exact same statistics. It just depends on what your preference is. So next, we're going to look at linearity with a scatter plot. Go to Graphs and Chart Builder. And in Chart Builder, you're going to select Scatter Plot, and then you're going to select the scatter plot with the built-in regression line and click and drag that to the above chart preview area. Then remember, dependent variable is always going to be on the y-axis. So you're going to grab your dependent variable and click and drag it to the y-axis. And then for me, I'm just looking at waist to hip ratio because it's a continuous variable. And I would click and literally drag it to the x-axis. Click OK. And you can see it pops out here. Not surprising, there's very little correlation. There's hardly a linear relationship here at all. You can see my regression line way, 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 way down there. It's almost completely flat. So, you know, the linearity here, there's really not much of an association here at all. So next we're going to look at multicollinearity diagnostics. This is fairly simple. You go to Analyze, Regression, Linear again, and go to Statistics. And under Statistics, usually, again, these are all not checked, but I click Descriptives, R-squared change, and Model Fit, and also collinearity diagnostics. So when you go to the output, first you'll see under the coefficients block, of course, you will in fact see the coefficients, and these are the unstandardized and standardized parameter estimates that you will be reporting. But also in this column, you'll see the collinearity statistics when you click collinearity diagnostics. You'll see tolerance and VIF in these last two columns. And again, you will see the cutoffs in the module for those two measures. Also in collinearity diagnostics, you want to look at condition index, and that is the following block, the second column in condition index. You want that to be less than 30, and as you can see in this example, this last variable potentially is problematic. So the last thing is linearity and correlations in that matrix graph. And how you get to that is you go to Graphs and down to Scattered and Dot, and then you click on Matrix Scattered, Define. And I've already included all of the variables of interest in here, gender, waist to hip ratio, anxiety disorder, and you just click OK. And as you can see, I mean, gender is dichotomous, so obviously those scatter plots are going to look very, very odd. There's not a whole lot of linearity here, or really, sorry, associations or correlations. All of the correlations are straight lines, or really not at all that and the gender is difficult to interpret. So going back up to the regression output, I'm just going to point out one more time where the parameter estimates are, and the ANOVA, which is the overall model fit. Let me know if you have any questions at all, and I hope this was helpful.